Hi, so wrapping up class for this summer, we are looking back at each of our research analysis projects and summarizing what we learned and how we've been able to apply that to our current jobs or future jobs. I chose to begin with differentiating data, information, and knowledge. It was actually our second assignment, but I thought it was important to distinguish the difference to then be able to discuss data analysis and how it supports decision making, and to at last using data analysis for optimization. So first looking at the different photos down here that distinguish the difference between data, information, and knowledge. In the first photo, you notice it's black and white little photos. In the second one, there's been color added. And then to the third, where they've been sorted and they are showing lines that are connecting the information. And then we go even into a little bit more detail down in the bottom pictures that we will discuss later. So what is data? What we see here in the photo is unstructured data. It's raw, unorganized symbols and characters. It can be quantitative or qualitative with words, numbers, and percentages. It can be measured in bits or bytes, and for any of these to be meaningful, they have to be processed. So here we see another example of data, but this time it's structured. Data is low-level knowledge that is not reliant on information for it to exist, but it is dependent in order for it to be understood. Data alone is not helpful in decision-making, but when it is processed and manipulated into information, it becomes useful. Examples of data are test scores, prices, phone numbers, names. You see in the example, there's county, the USA, there's dates, ID numbers, etc. So now that the data has been processed into information, what exactly is information? The photo, while technically is just a visualization of the data, it can support with the communication of the thoughts and ideas generated from the manipulation of the data. Information is a refined form of actual data measured in time and quantity. To understand this better, a birthday is just a date without knowing whose birthday it is. People, and now even machine learning, have the capability to create information from data. So last is knowledge, and knowledge is simply applied information. The application is unique to every person based on their experience, education, and insights, which in turn determine how they will interpret and give meaning to the information. In this photo that we started with, you see a continuation of insight, wisdom, and results. And this comes with time and the experience piece. When you have a new product launch, you're in the first row. And when you're in the second and third week and you have the insights of your product launch and to help aid in decision making, and when you've done your 100th product launch, you have the wisdom piece. And you get more effective and better and efficient at driving profits. There are two types of knowledge, both reliant on data and information. And these are implicit, which is documented knowledge like a textbook and encyclopedias. And then there's explicit, which is not written down, but just something that you have knowledge in, that you've acquired at some point. Think of this as an example of like riding a bike. You were taught at one time. You might remember learning to ride a bike, but most likely you don't. But at any point, 10 years from now, you can still get on a bike and ride it. So here's another example like the birthday. To someone unfamiliar with running a retail store, there is structured data here with numbers and labels, but does not quite become information because it's lacking the knowledge of the business processes at this particular company or industry. Without knowledge, there's no significance to this data to make a decision to impact the business's profitability. Meaning you wouldn't be able to walk into the store and look at this document and be able to make a profitable decision. So next, we're going to look at business analysis, and we're going to come back to this document and see how it's used in decision making. Decision making, what are the steps? So first, what is the problem? For retail, is it being more profitable or cutting costs, or both? Next, create the data. What data is needed to make a decision? How will we create information from this data? What model could be used? What visualization could help support? What tools are available to predict and assess your possible decisions or outcomes? Now there can be a noticeable decision made when you use these steps to support the information and data. The model shows the simplification of this. So you see, identify the problem, you have two possible solutions, and then what are the outcomes of those solutions? And then once you decide, you monitor and then impact or change your decision based off of the results of that decision, and continue to gather that information and again, repeat the process. So here we come back to the data from earlier. So this data is used for a manager in retail to make a decision. So for example, say it's halfway through a Monday and the store is not hitting their forecasted sales. So the manager has to make a decision, a business decision to impact profits, correct? So there's an explicit knowledge that there's two ways to impact the business results, and that's either one through conversion or two through average dollar sale. So they can either focus on getting as many customers in the store to purchase or make a purchase, or they can focus on getting some of the customers to spend as much money as possible. Now, why not do both? Well, there's a trade-off there. When there's only so much time, it's not possible to get to every single customer and also sell them as much. As you know, if you're going to sell them more, it's going to take more time. If you're going to spend more time with that customer to show them more options to buy, that's going to take more time and take away from maybe getting to as many customers. So which should she focus on? There's also explicit knowledge. There's a wisdom there that you know which one to focus on, but there's also a qualitative or statistical support that we can gain for this decision, and that's through correlation. So when we look at the output from the Excel document below, we see that conversions correlation is a 0.99113 and ADS is a 0.9743. And based off of correlation, we know the closer to 1, the heavier the impact it'll have on the outcome, correct? So we know that conversion is the answer here, which I did know that. Conversion is always the answer. If you sell to more people, you'll gain more profits. But to the point is if you look at both of them together and you focus on both of them, it's at a 1, which means that if you can find a balance between the two, you'll have the highest output. So obviously, if you focus on conversion too heavily and they only spend $10, then you could actually probably get farther with average dollar sale in some cases. But statistically showing, you should be able to be the most profitable with focusing on conversion. And then through lots of training of associates and talent, you get in the balancing of the two. So in this moment, though, the correlation indicated that conversion will maximize profits more quickly than ADS. So now next we're going to talk about optimization and why it permeates a trade-off between the two. So optimization is meant to maximize profits or minimize expenses. So first decide which of these two is the goal. List the variables and constraints and then test the feasibility region or possible outcomes to find the best possible outcomes. The last example was an optimization to maximize profits. The steps in decision making are the vague outline of the steps to optimization. So here we're going to look at optimization of payroll, which goes hand in hand with running a retail business in our last example. Here we see the variables and constraints for a schedule. We need 40 people for the first 4 hours, 10 for the next 4 hours, and so on. So looking at these steps in more detail, we know that payroll's objective function is almost always minimization. Some of the most common variables are the number of associates needed, hours of operation, and sales. Common basic constraints are associate availability, flex points, and coverage requirements. Since these variables are all directly dependent on each other for the results of the outcome, they are considered linear and can use linear optimization to solve for the most efficient outcome. Here in the photo, you can see at 0400 and 0800, there are 15 extra people as well as at 1200 to 1600. The last example gives the outcome for the linear optimization from solver for the best number at each shift. Staggering them for a better support and less total spend here is the example. In this specific example, the spend is the same. So Typically in real life, though, the outcome would be that there would be less spend, where here there's both 640 hours spent between the two, but they were able to optimize where there was 15 extra people in two areas and then maybe just flat coverage in the other. It's a little more staggered throughout the day, so it's a little bit like all the requirements are met, and then the overlay is a little bit more even for creating a better overall experience for everyone. Where when you're looking at a real life example, where the actual outcome is to increase profits while spending less in payroll. So being very specific, say for example, $1,000 equates to 3 hours of payroll, or that's 3 associates for 1 hour, same as the example. So if you make an extra $500, you would earn an extra hour, or if you didn't, like you missed goal by 500, then you would lose an hour and a half. So what makes this not linear for retail in real life, as we saw in some of our past exercises, is that one of the main variables here is the associate's performance or productivity, which makes this a much more complex modeling, and is where machine learning software is very beneficial, especially when it's able to give you those predictive and prescriptive outcomes of knowing your results and those associates' results. So in conclusion, what we've learned is that in our employment, the data that is kept and gathered on our systems, we learned how to take that data and make it into information to make decisions that optimize profitability or minimize the cost at what we are getting to that profitability, and the tools that are available to us in order to get to those decisions and communicate that information to support, in some cases, to our bosses, or as a manager to defend the decisions that we make at times. So in the example that we talked about, I gave, how complicated the data could be in order to support these decisions. And, as throughout this class, we've learned lots of different tools. And in this last discussion, we were able to explore even further tools that continue to evolve to better support these decisions and only make us more successful if we know how to gather and create the data to optimize those decisions for us for best results.